Hello, this is Ms. DB. In this video, we're going to review Chapter 9, Section 1, Identifying Quadratic Functions. Our objectives are to identify quadratic functions and determine whether they have a minimum or maximum and what that number, that coordinate is, and to graph quadratic function and give its domain and range. Here's an example of a quadratic function. This is y equals x squared. This is the most simple quadratic function you can have. It's called the parent function. The graph is not linear. It has a curve, so it's not linear. It is any function that can be written in the standard form y equals ax squared plus bx plus c. A, b, and c have to be real numbers, and a cannot be 0. B and C can be 0 because you can see in this one they are 0 because it's just y equals 1x squared, or you could write y equals x squared. So this fits the model of the quadratic function, or you can tell by its graph that it's quadratic as well. Another way we can tell that it's quadratic is by looking at how the x and y values change if you have a table of values. So if you have a table of values, or if you make a table of values, we're going to look at how the y values change as the x values increase by a constant amount. So here our x values are increasing by 1 each time. We go from 0 to 1 to 2. Every time it's add 1. If the y values also increase by the same amount, that's called the first differences, then it would be linear. We've looked at that before. But it does not look like the first differences are increasing by the same amount. From 0 to 1 is plus 1, but from 1 to 4 is plus 3. So again, first check the x values, that they are constantly increasing by the same amount. They have a constant change. Then we check the first differences, and they're not the same. 1, 3, 5, and 7. But we can also check the second differences. So I'm going to take the differences of the differences. So 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. The second differences, the differences of the differences, are constant. That is a sign that this is a quadratic function. So here's an example. We have our x values here and our y values here. The tables can either be horizontal like in the last one or vertical like in this one. So first we check that the x values are increasing at a constant rate. These are all increasing by plus 1, so that's good. If that's true, now we're going to check the first differences of the y values. So let's check if from negative 9 to negative 2 and negative 2 to negative 1, how they're increasing. Well, negative 9 plus 7 is negative 2. And negative 2 plus 1 is negative 1. And then plus 1 to get to 0, and then plus 7 to get to 7. So these are not constant. It's not linear. Let's check the second differences. 7 to 1, you would subtract 6. That's minus 6. From 1 to 1 there's no change, so that's plus 0. And then from 1 to 7 is plus 6. The second differences are not constant. This is not quadratic. So it's not linear, it's not quadratic, and we could do some other things to find out if it's a different kind of function, but we won't worry about that until another day. All right, let's look and see if this function is quadratic. So we have y equals 7x plus 3. I could make a table of values and look at the first and second differences, but we could also look at it as an equation. So we have y equals 7x plus 3. That does not fit the model for a quadratic function. The quadratic function is supposed to be ax squared. We don't have an x squared term. If there was an x squared term, then a must have been 0, and that's not something you can have to be quadratic. Let's see if this one's quadratic. So we would put the plus 10x to the other side, rewrite it in standard form, it's called, and now does it fit the model? It does now. It can be written as y equals something x squared plus something x plus c, and it happens that a is 10, b is 0, and c is 9. So this is a quadratic one. On your assignment, you're going to tell whether the functions will be linear, quadratic, or neither. So the first thing to do is check that the x values are all increasing by the same amount. And if they are, then we'll look at the first differences. If they're constant, it's linear. If they're not constant, then we'll check the second differences. If the second differences are constant, then it's quadratic. Let's just do number 1. From -4 to -1, we would add 3 to do that. From -1 to 2, we would also add 3. To get from 2 to 5, we would also add 3. And to get from 5 to 8, we would add 3. So the x differences are constant, so that's good. Let's look at the first differences for the y values. To go from 43 to 16, we're going to have to subtract something. So you can use a calculator if you want and do it in reverse order. Go 16 minus 43, and it's -27. Now we're going from 16 to 7. And again, that's decreasing. So you can go 7 minus 16. We should get a negative answer, and it's -9. From 7 to +16, now we're adding 9. And from 16 to 43, we're adding 27. These are not constant, so it's not linear. Let's go on, and if it's not linear, maybe it's quadratic. So let's check our second differences. So now we're going to go from -27 to -9. I know I'm going to add something. So you can take, if you want, you can use your calculator and go -9 minus -27. Or if you know kind of in your head, this is going to be +18. Now we're going from -9 to +9. If you think about temperature outside, you're at -9 and you go all the way up to +9. That's also a change of +18. And from 9 to 27 is also a change of +18. So these are our second differences. And they're constant. They're all the same. That's what constant means. So this is a quadratic function. This is number 1. It's quadratic because the second differences are constant. And then for number 2 and 3, you would do the same thing and decide if the first differences are constant, then it's linear. If it's linear, you would stop and not find the second differences. If it's not linear, if these are not constant, then continue and see if these second differences are constant. If yes, stop and say it's quadratic. If not, you would have to say neither. All right, let's look at the graph of a quadratic function. It's this curved figure, kind of like a U shape or an upside down U, and it's called a parabola. To graph this, we can either pick a bunch of values of x and make a table of values and find what y is, and then graph lots of points, connect those points with a smooth curve, or you can use Geometer's Sketchpad or a graphing calculator or the online graphing calculator desmos.com. All right, let's try the table of values method. So here we have y equals 1/3 x to the second power. This is a quadratic. So we're going to make a table of values. You can pick whatever values of x you want. Don't pick too big of numbers because then it'll make it hard to solve and find what y is. So if x is -2, boy, they did those fast. Let's go over here and find how did they get that. That would be 4/3. So you would plug in -2 in parentheses squared. That's when x is equal to -2, this one here. And that means we have 1/3 times -2 squared. -2 squared, -2 times -2 is a +4. And the rule for multiplying fractions is put a 1 for the denominator and then multiply straight across the top and straight across the bottom. So 4/3, that's how they got that. When x is -1, put in -1 in parentheses and square it. Whenever it's a negative, put it in parentheses. -1 squared is the same as 1. So that's how they just got, that's just equal to 1/3. Anything times 1 is equal to itself. For 0, 1/3 times 0 squared, anything times 0 is 0. For 1, we'd have 1/3 times 1 squared, but 1 squared is 1, so we have 1/3 times 1, is just 1/3. And then for the very last one, we would have very similar to the first one we did, 1/3 times positive 2 squared. So 1/3 times 4, put a 1 underneath, and on the top, the numerator would be 4, and the denominator would be 3. Now that we have that table of values, we're going to graph those points, and then graph them. Let me get my eraser. And you can see that those points make a nice curved parabola. And it's a little bit tricky to graph with the thirds, but you can do it. Here's another example. I'm just going to go through this one quickly. You can come back and look at it if you want on your own. What I want to show you is how to make these graphs at a graphing calculator, online graphing calculator. So the first one that we're going to do is y equals x squared. Now that one would not be hard to graph using a table, so you can graph that by hand if you want. Oops. And the second one is y equals negative x squared minus 2. So I'm going to go to this graphing calculator. I think it'll go. And show you how to use Desmos and how to share your graphs once you make them at Desmos. It doesn't seem to want to go. All right, so now I am at Desmos.com, and if you remember, the first one that I wanted to graph was y equals x squared. This is y equals x. To make y equals x squared, I could use this button, and that will square it. Or you can use, where's the power button? I know there's an exponent button on here somewhere. Oh, it's this one. You can type this and then pick that you want it to be x squared, this a to the b. So this is the graph. That's all you have to do. Now you could make a table of values. I'll show you how to do that too. So here's your table of values. You go to this thing, add item, pick table. Then when you're at the table, you can pick the values for x. I'll go -2, -1, 1, 2. Oh, I didn't put 0. That's okay. Now, if the function that I want to do is y equals x squared, then I need to square each one of these. So -2 squared is 4. -2 times -2. -1 squared is 1. 1 squared is 1. 2 squared is 4. So you can make a table of values if you want, or you can just type in the graph. Either one is fine. Now this is the graph. This is what you need to share. You could take a screenshot of this and then paste that into the worksheet. Or if you go up here to this button here, it means share graph. One way is to print it, which you could print to like an image or a PDF. And there's other ways here too. The easiest way is just to copy this link. Copy. Now I'm going to go back to the PowerPoint slideshow, except I'm going to go to the part that doesn't have, this is not the slideshow, this is where I actually did the work. And I want to show you how you would add this to a worksheet. Like let's say this was the worksheet, you would just go to Control V, which is copy paste. So that's really large. It wouldn't be so big on your worksheet. So this is the link to the graph. And now I'm going to go ahead and go back to the slideshow. And when I open up your worksheet, I can click on this. I don't know how well this is going to work. It took a long time. Oh, it looks like it's working already. It's going to take me right to your graph. This is the graph that you made. You shared me your link with me, and there it is. So it works really nice that way. Okay, I was going to make another graph, and the other graph that I was going to make was number 2 was negative x squared. So you can type in the y equals part, y equals negative, and I just typed the negative sign from my keyboard. You could also use the minus sign here. And then x squared. So that flipped it over the x-axis, so now it's upside down, and then it still said -2. So I'm going to hide this keyboard so you can see it better. You can also zoom out or zoom in. You can also grab it and move it around. So when you can see it real well, then go again to Share, and if you want, you can just copy the link, or you can take a screenshot and you can paste it into the worksheet. So whatever works best for you there. And then you would paste your other one on the worksheet as well. All right, so you can graph these also in Geometry Sketchpad, and then you could just save the Geometry Sketchpad file and attach it. That would be fine too. So in the last couple, we saw that, I'll just, where's my pencil? This first one looked something like this, and the other one looked something like, let's see, at 0 it would be at -2, something like that. Whoops, that went really, that's terrible, but it's hard to draw these by hand, especially with a mouse. All right, so when a is positive, it'll open upward. When this is a positive number in front of the x squared term, when it's negative, it'll open downward. So whenever the first term in front of the x squared is a positive, then it is going to open upward. Whenever it's a negative in front, then it'll open downward. So the next few problems, you just have to say whether they open upward or downward. However, you can see like in this one, sometimes they're not y equals right away. So the first thing you'd have to do in this problem is add 1/3 x squared to both sides, which really it's just rewriting it, so that now you can tell, is this number in front of the x squared term positive? Then it opens upward. If it's negative, it opens downward. So first get it in standard form where it's equal to y, and then decide if a is positive or negative, and then say whether it opens upward or downward. Here's another example. Again, this one is not in standard form. First, rewrite it. The x squared term needs to be written first. And remember that the sign in front of a term goes with it. So this would be -3x squared plus 5x. That's going to open downward because it's -3. On your worksheet, numbers 6, 7, and 8 are already written in standard form. So you just have to identify what is a, and then say whether it opens upward or downward. But in number 9, this one is not solved for y yet. So for number 9, you would first need to make it so that it's y equals instead of all this other stuff. So how can I move the -5x squared? I could add 5x squared to both sides. Then I would have y, I still have plus 25, equals 5x squared. It's still not y equals. I don't want the plus 25, so I'll subtract 25. Now remember, when you do this, you don't actually add or subtract the 5 and the 25 because they're not like terms. So you just rewrite that. So now it's in standard form. Now I can identify what is a. A is 5. This is where you were supposed to write the rewritten form. And so a is positive, so then we can see that the graph would open upward because a is positive. The highest or lowest point on a parabola is the vertex. If a parabola opens upward, the vertex is the lowest point. That's also called the minimum. If a parabola opens upward, the vertex is the highest point. That's also called the maximum. Here's a couple examples of what that could look like. Here we have a parabola that opens upward. It would have a minimum. Its vertex is that point where it turns and then starts going up. So it's going down, stops, turns, goes up. The vertex on this one is at -3, 0. It needs an x and a y value. And the minimum is just the y value of the vertex. So the minimum or max is the y value of the vertex. In the second picture, this parabola has a maximum. So identify the vertex, and then from there you can see that the maximum is 5. So that's exactly what we do here. We identify what is the vertex and then say whether it has a minimum or maximum and what is that value. So in this one we have the vertex is at -3, -1, -2, -3, 2. It has a minimum and that value is 2. In the second example, the vertex is at 1, 2, and 5, 2, 5, and it has a maximum which is at 5. And then domain and range. In quadratic functions, the domain is almost always all real numbers. So you write that for the domain, you say all real numbers. The range, it will be depending on what kind of function we have, what the other numbers are. In this one, you can see that the domain is all real numbers. There's any number you could use for x that you want. Anything would work. There's no holes, there's no place where it stops or you wouldn't be able to use it. The range is it never goes below this line here. The lowest it ever gets is 1. So you would say that the domain is all real numbers. The range is y is greater than or equal to 1. Let's find the domain and range of this one. The domain is all real numbers, like it will be for almost all of them. The range is y is always less than, let's see, -1, -2, -3. Y is always less than or equal to -3, isn't it? That's what you write for the range. So here's the domain, all real numbers. The range, use a capital R and write y is less than or equal to -3. So the domain is what can the possible x values be, and the range is given what your x value can be, which is anything, then what are the possible y values that you get. Let's look at number 11 on your worksheet. Here it is. First of all, we're going to identify the vertex. So here's the vertex, there's a dot there. It looks like it's over -2. So the x value is -2, and it goes down -1, -2, -3, -4, -5, -6. So -2, -6 is the vertex. Now this is opening upward, so it has a minimum. And that value is the y value of the vertex, so that would be -6. Now, it's not a special quadratic. We don't have a real-world situation saying that it can't be something, so we just write, as we will for most of these, all real numbers for the domain. Now, for the range, we have to look at what will y always be greater than, because this one's opening upward, so y is always going to be greater than this point right here. See, it's never goes below that point. So then we write y is greater than or equal to the lowest point it ever is, which is also equal to the minimum. And that is y is greater than or equal to -6. So look back at your minimum or maximum to see what your range is going to be. They will be related to each other. Now in number 10, I'll just start this one. In number 10, the domain is already given as all real numbers. For the range, it's going to be y is less than or equal to whatever the maximum value is. So you look at here and you're going to write the vertex in. It's got a maximum. And then what is the y value of the vertex? And that's what you'll put in here for y is less than or equal to whatever that maximum point is. Don't write maximum. You write the number that is the maximum there. All right. Have fun on this worksheet. It's kind of nice to get to do some quadratic functions. And if you have any questions, please let me know.